common electrical installation involves using a feed-through panel with two 200-amp main breakers. The inspector's concerns may stem from a misunderstanding of how these systems operate. One potential concern involves a power surge scenario. If a power surge exceeding 200 amps occurs, both breakers will trip as designed. However, the inspector might be concerned that when power is restored, only one breaker will reset, leaving the other tripped. This is due to the fact that both breakers need to be manually turned off and then back on to reset. If only one breaker is reset, the other will remain tripped, effectively keeping the power off at the meter. This situation is not inherently a problem, as it ensures the electrical system remains protected. Another possible concern centers around the presence of a disconnect at the house. The 200-amp breaker in the house serves as a disconnect for the specific panel. It provides a means to shut off power to the panel for maintenance or in case of an emergency. To address any lingering doubts, it is advisable to consult documentation from Square D regarding the use of feed-through panels. This documentation outlines the reasons why using a feed-through panel is an acceptable and safe practice. If the inspector remains unconvinced, contacting Square D directly for additional documentation or clarification may be beneficial. It's important to remember that electrical codes and interpretations can vary, so having supporting documentation can help resolve any discrepancies. The inspector may also be thinking of a scenario where there is a fault in the house panel. If there is a short circuit or ground fault, the 200-amp breaker in the house panel should trip. If this breaker fails to trip, the 200-amp breaker in the garage will trip. This provides a backup protection in case of a failure of the house panel breaker. The inspector may also be concerned about the load in the service. If the total load in the house exceeds 200 amps, the 200-amp breaker in the garage will trip. This is why it is important to properly calculate the load on the service before installing a 200-amp panel. If the load exceeds 200 amps, a larger service will be required. It is also important to ensure that the wiring is properly sized for the 200-amp service. The wiring should be sized according to the National Electrical Code NEC. The NEC provides tables that specify the minimum wire size for different ampacities. It is important to consult these tables to ensure that the wiring is properly sized. Another consideration is the type of conduit used for the underground service. The conduit should be rated for underground use and should be properly installed. The conduit should be buried at the proper depth and should be protected from damage. It is also important to ensure that the conduit is properly sealed to prevent water from entering. Water can damage the wiring and can create a safety hazard. The feed-through panel should be properly grounded. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electrical shock. The grounding system should be installed according to the NEC. The NEC specifies the requirements for grounding electrodes, grounding conductors, and bonding. It is important to follow these requirements to ensure that the grounding system is properly installed. The feed-through panel should be properly labeled. Labeling helps to identify the purpose of each circuit breaker. The labels should be clear and easy to read. The labels should also be durable and should be able to withstand the environment. The feed-through panel should be properly inspected. A qualified electrician should inspect the panel to ensure that it is properly installed and that it meets all applicable codes. Inspection should include a visual inspection, a continuity test, and a voltage test. The electrician should also verify that the grounding system is properly installed. Proper installation of a feed-through panel is paramount for safety and functionality. Here are some additional points to ensure a robust and code-compliant installation. Firstly, verify the ampacity of the service entrance conductors. Ensure that the conductors feeding the 200-amp feed-through panel are appropriately sized to handle the full 200-amp load. Refer to NEC Table 310.15b16 to determine the correct conductor size based on the conductor's insulation type and the ambient temperature. Secondly, consider the short circuit current rating SCCR of the panel. Ensure that the feed-through panel has an SCCR adequate to handle the available fault current at the installation location. This information can typically be found on the panel's label. The available fault current should be determined by the utility company or a qualified electrician. Thirdly, pay attention to the neutral and grounding connections. The neutral conductor must be properly sized and connected to the neutral busbar in the panel. The grounding electrode conductor must be properly connected to a grounding electrode system, such as a ground rod, ground ring, or metal water pipe. Refer to NEC Article 250 for detailed requirements on grounding and bonding. Fourthly, consider surge protection. Installing a surge protective device (SPD) at the feed-through panel can help protect sensitive electronic equipment from voltage surges. SPD should be selected based on the voltage and current requirements of the electrical system. Fifthly, ensure proper overcurrent protection. Each circuit breaker in the panel must be properly sized to protect the connected circuit. The circuit breaker should be rated to trip at or below the ampacity of the circuit conductors. Refer to NEC Article 240 for detailed requirements on overcurrent protection. Sixthly, use appropriate wiring methods. The wiring methods used for the installation must comply with the NEC. Common wiring methods include conduit cable and wireway. The wiring method should be selected based on the application and the environmental conditions. Seventhly, maintain proper working clearances. Sufficient working clearances must be maintained around the feed-through panel to allow for safe access and maintenance. Refer to NEC Article 110.26 for detailed requirements on working clearances. Eighthly, provide adequate ventilation. The feed-through panel should be installed in a well-ventilated area to prevent overheating. Overheating can damage the panel and can create a safety hazard. Ninthly, follow manufacturer's instructions. Always follow the manufacturer's instructions when installing a feed-through panel. The manufacturer's instructions provide detailed information on the installation, operation, and maintenance of the panel. Tenthly, document the installation. Keep a record of the installation, including the panel's model number, serial number, and date of installation. This information will be helpful for future maintenance and troubleshooting. It's also important to understand the purpose of a feed-through panel. A feed-through panel, also known as a main lug-only MLO panel, is a type of electrical panel that does not have a main circuit breaker. Instead, it receives power from a remote main breaker, such as the one in the garage. The feed-through panel is typically used in subpanels or remote distribution panels. The purpose of a feed-through panel is to provide a convenient and cost-effective way to distribute power to multiple circuits. By using a feed-through panel, it is possible to avoid the need for a separate main breaker for each circuit. This can save space and money. The feed-through panel must be properly labeled to indicate that it is fed from a remote main breaker. The label should be clear and easy to read. The label should also indicate the location of the remote main breaker. The feed-through panel must be properly grounded. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electrical shock. The grounding system should be installed according to the NEC. The NEC specifies the requirements for grounding electrodes, grounding conductors, and bonding. It is important to follow these requirements to ensure that the grounding system is properly installed. The feed-through panel must be properly inspected. A qualified electrician should inspect the panel to ensure that it is properly installed and that it meets all applicable codes. The inspection should include a visual inspection, a continuity test, and a voltage test. The electrician should also verify that the grounding system is properly installed. The panel schedule should be updated to accurately reflect the circuit served by the panel. Each circuit breaker should be labeled with a description of the load it serves. The panel schedule should be kept in a safe and accessible location. It is also important to understand the concept of selective coordination. Selective coordination is a design practice that ensures that only the overcurrent protective device closest to a fault will trip, minimizing disruption to the rest of the electrical system. In a system with multiple circuit breakers in series, such as a feed-through panel installation, selective coordination is achieved by selecting circuit breakers with different time current characteristics. The upstream breaker, such as the 200 amp breaker in the garage, should have a longer time delay than the downstream breakers in the house panel. This allows the downstream breakers to clear fault before the upstream breaker trips. Selective coordination can be achieved by using circuit breakers with different trip curves or by using fuses with different time delay characteristics. It is important to consult with a qualified electrical engineer to ensure that selective coordination is properly implemented. In addition to selective coordination, it is also important to consider the impact of voltage drop. Voltage drop is the reduction in voltage that occurs as electricity flows through a conductor. Excessive voltage drop can cause equipment to malfunction or fail. The NEC provides guidelines for limiting voltage drop. The NEC recommends that voltage drop should not exceed 3% for branch circuits and 5% for feeders. Voltage drop can be calculated using a variety of formulas. The most common formula is Ohm's law, which states that voltage drop is equal to the current multiplied by the resistance of the conductor. To minimize voltage drop, it is important to use conductors with a low resistance and to keep the length of the conductors as short as possible. It is also important to ensure that the conductors are properly sized for the load. When installing a feed-through panel, it is important to consider the location of the panel. The panel should be installed in a location that is easily accessible and that is protected from the elements. The panel should also be installed in a location that is free from obstructions. The panel should be mounted securely to a wall or other supporting structure. The panel should be installed in accordance with the manufacturer's instructions. It's also important to choose the right type of feed-through panel for the application. Feed-through panels are available in a variety of sizes and configurations. The size of the panel should be selected based on the number of circuits that will be served by the panel. The configuration of the panel should be selected based on the wiring requirements of the installation. Some feed-through panels have a main lug-only MLO configuration, while others have a main circuit breaker. The MLO configuration is typically used in subpanels or remote distribution panels. The main circuit breaker configuration is typically used in service entrance panels. Another important consideration is the type of enclosure used for the feed-through panel. The enclosure should be selected based on the environmental conditions of the installation. Enclosures are available in a variety of materials such as steel, aluminum, and fiberglass. Enclosures are also available in a variety of ratings such as NEMA 1, NEMA 3R, and NEMA 4X. NEMA 1 enclosures are intended for indoor use only. NEMA 3R enclosures are intended for outdoor use and provide protection against rain, sleet, and snow. NEMA 4X enclosures are intended for both indoor and outdoor use and provide protection against corrosion, water, and dust. The electrical inspector may have a different preference, but what you are proposing is safe.